Hey everybody, it's Miss Berry. In this video, we are going to cover section 1.5, which is called Properties of Equality and Writing Two-Column Proofs. So we're going to spend a little bit of time looking at all of the properties of equality, and then we're going to use those properties of equality to begin writing proofs. So here are our properties of equality. If you're not working off of the guided notes, then you definitely need to take a second, pause the video, and write all these down. If you are working with the guided notes, then these are all on the notes. All right, so we have, let's see, 8 properties of equality here. And these are all just written sort of shorthand. They all have the longer version of their name. For example, here would be addition property of equality, subtraction property of equality, and then down here, reflexive property of equality, symmetric property of equality, right? So these are all properties of equality. And we can also see that reflected over here in the actual properties. You can see that each one of them contains an equal sign, all right? So each one of them contains an equal sign because they are a property of equality. All right, so it says let A, B, and C be any real numbers. All right, so these are any real numbers. The addition property of equality says if A is equal to B, then if you add C to both sides, those are still equal. All right, so A plus C is equal to B plus C. All right, so since you're adding the same value to both sides, that equality remains true. All right, similar property here, the subtraction property of equality says if A is equal to B and you subtract C from both sides, then that equality still holds. So A minus C is equal to B minus C. Multiplication and division properties are very similar. It says if A is equal to B, then A times C is equal to B times C. So if you multiply by the same value on both sides, that equality holds. And then the last property here, if A is equal to B and C is not 0, we're not allowed to divide by 0, so they just specify that C is not 0. All right, so if A is equal to B and C is not 0, then if you divide both sides by C, that equality still holds. So A divided by C is equal to B divided by C. All right, so those are our 4, standard operations and their corresponding properties of equality. All right, the bottom 4 may be less familiar to you. The reflexive property, very straightforward. It just says A is equal to A. So 2 is equal to 2. X is equal to X. Right, so if A is any real number, then A is going to be equal to itself. The symmetric property of equality says that if A is equal to B, you can switch the order and say B is equal to A. Okay, so if A is equal to B, then B is equal to A. Transitive property, this is the one that people struggle with the most, so I want to put a little star by this and say, let's see, that's the one that people struggled with the most in this previous semester. All right, so I'll give you an example with actual numbers on the next slide, but the transitive property of equality says if A is equal to B and B is equal to C, then A is equal to B, which is equal to C, which means that A is equal to C. All right, so if A is equal to B and B, so that very same B, if that B is equal to C, then A is equal to C. All right, so transitive, think it like kind of translates across those equations. So A is equal to B, B is equal to C, so A is equal to C. All right, and then this last one got cut off. It's the substitution property. It just says that if A is equal to B, then B can replace A in any expression. All right, so let's just write that down here, in any expression. All right, so if A is equal to B, then B and A are interchangeable, essentially. All right, so B and A are interchangeable. All right, so let's take a look at the transitive property a little bit more closely. And just before we do that, I just want to mention that these properties, these are things that you're going to want to add to your formula sheet for the first test. All right, so make sure you have these on the formula sheet. All right, and then, let me see, there we go. The addition, subtraction, multiplication, division properties, these are really, you're not going to see them come back up. Maybe 1 or 2 times they'll come up in the remainder of the semester, but we will see this reflexive, symmetric, transitive, and substitution property be used over and over and over, so you really want to familiarize yourself with those properties of equality. All right, so let's look at an example of the transitive property just so you can get an idea of what it looks like with actual numbers. All right, so let's say that you're given this statement. X is equal to 2 and Y is equal to 2. All right, so X is equal to 2 and Y is equal to 2. Well, the transitive property tells us that if X is equal to 2 and Y is equal to 2, then X is equal to 2, which is equal to Y. Right, so I've just restated that first line. X is equal to 2, that came from here. Y is equal to 2, that came from here. And then I can drop out this middleman here and be left with X equals Y. All right, so this is an example of the transitive property. If X is equal to 2 and Y is equal to 2, then X is equal to 2, which is equal to Y, or we can say that in a shorter way by saying X is equal to Y. All right, so hopefully seeing that with actual numbers kind of solidifies that property and what the purpose of that property is. So it allows us to get another sort of like shorthand, sort of combining everything into one little statement. So it allows us to take this kind of long statement in the first line and condense it down into this short little equality. All right, so we're going to be writing 2-column proofs in this section. This is something that you may not be familiar with, or it may be something that you haven't done in a long time. So before we start, I'm just going to start off with an example of something that you probably are familiar with and that you have done recently. And we're just going to talk about at each step of the way, how did we know that we're allowed to do that? So we're just going to solve for X. And as we're solving, we're going to make note of the properties that we're using. All right, so we have this equation, 3 times, then a parenthesis, X minus 2, close parentheses, equals 12. Now there's lots of ways that you could solve this. I can think of 2 different ways that you could solve this, but what I'm going to do is I'm just going to go ahead and multiply through. Let's see, there we go. Multiply through by 3 on the left-hand side. And we talked about in the last video that left-hand side, we abbreviate that LHS, especially when we're writing proofs. All right, so we're going to multiply through by 3 on the left-hand side. Now, we didn't mention this one, but that is called the distributive property, and hopefully that is something that you're familiar with. You probably heard about that in your algebra class. So the distributive property tells us that we can multiply through by 3 on the left-hand side, and that gives us 3x minus 6 equals 12. All right, so we just did 3 times x is 3x, 3 times negative 2 is negative 6. All right, now here's what we're working with, 3x minus 6 equals 12. We're trying to solve for x, so let's move that 6 over. So we're going to add 6 to both sides. All right, now we're allowed to add 6 to both sides because of the addition property of equality. It says if you're adding the same value to both sides, that equality still holds. All right, so if we add 6 to both sides, we get 3x equals 18. And again, we're trying to solve for x, so let's get rid of that 3. We can get rid of the 3 by dividing both sides by 3. Right now we're multiplying 3 times x, so we can get rid of it by dividing. So we're going to divide by 3 on both sides. The property that allows us to do that is the division property of equality. Right, and if we divide both sides by 3, we get x equals 6. Now this is essentially what we're going to be doing in this first section on proofs. So as we learn how to do proofs in this section, when we get to Unit 2, then we'll start doing proofs with geometry. But for right now, we're keeping it pretty basic. All of our proofs are just going to be algebra based. All right, so here's our first two-column proof. Proofs are generally written not in this way, but as you're learning, since this is, we're just learning how to write proofs here, this is a good way to start learning how to write proofs. They're broken up into two columns. The left column is the statements and the right column is the reasons. So here it's got all of the statements filled in, and then we're supposed to fill in the reasons. Sometimes that changes. Sometimes there'll be gaps on the left and then gaps on the right, or blanks on the left, blanks on the right. In my opinion, there's not, like, this one isn't particularly easier because the blanks are on the right versus the blanks being on the left. So I guess it's just personal preference. All right, so this says fill in the blank with a reason that justifies the statement. All right, so here's our statements. We're going to just read, see what's happening here. We have 2x minus 15 equals 39. That was given to us, so there's no algebraic reason there. Okay, sorry, I had to pause that for a second, so I'm just picking up from here. So the first line is just given to us. It's told that we're assuming that that's true. All right, but let's think about how do we get from line 1 to line 2? All right, so it goes 2x minus 15 equals 39, and then the next line says 2x equals 54. So how did we get from line 1 to line 2? All right, so think about that for a second. What disappeared? Where did it go? All right, so hopefully you were able to figure out that we added 15 to both sides to get rid of this. So we moved this to the other side by adding 15 to both sides. All right, so what property allows us to add 15 to both sides? That would be the addition property of equality. All right, so since we're adding on both sides, we are using the addition property of equality. All right, now let's look at line 2 to line 3. 2x equals 54, and then the next line says x equals 27. So what happened from line 2 to line 3? We divided both sides by 2. All right, so to get x by itself, we divided both sides by 2. All right, and what property is that? What property allows us to divide both sides by 2 and maintain that equal sign? That would be the division property of equality. All right, so hopefully this is all starting to make sense. We're going to do lots of examples, but we're going to do another example kind of similar. All right, so again, a similar example. All of the statements are filled in. The reasons are blank. So it just says fill in the blank with the reason that justifies the statement. All right, so let's take a look. The first line is given to us, so that means you're going to assume that this equation is true. All right, so it says 1/2 x, or 1 over 2x, minus 4 equals 11. All right, the next line looks like we've multiplied by 2 over here. We've got 2 and then parentheses around that original left-hand side. And then 11 changed to 22, so we've multiplied by 2 on the right. All right, so we've multiplied both sides by 2. What property allows us to multiply both sides by the same value? The multiplication property of equality. So you can see I'm just abbreviating property of equality there, POE. All right, now let's look at the next line. It goes from 2 times 1/2 x minus 4, close parentheses, equals 22, to x minus 8 equals 22. So it looks like we've multiplied through by 2. We've distributed that 2 on the left-hand side, and the right-hand side has remained the same. All right, so we've just distributed, we've multiplied through by 2 only on the left-hand side. So think about the fact that we only multiplied on the left-hand side here. Remember, the right-hand side stayed the same. So since only the left-hand side is changing, that's not one of our properties of equality. Right? On our properties of equality, that was saying, hey, if you do something to both sides. Right? So that's not one of our operation properties of equality. So addition, subtraction, multiplication, division. This time that's going to be the distributive property. Right? So the distributive property allows us to multiply through but on one side while leaving the other side alone. All right, and then from line 3 to line 4, we've got x minus 8 equals 22, and then the last line is x equals 30. So what happened from line 3 to line 4? we added 8 on both sides, right? So we added 8 to both sides. That canceled out the 8 on the left. 22 plus 8 is 30. Right, so what property allows us to add 8 to both sides? The addition property of equality. All right, so this is kind of the way that I want you to, work through these problems when you're on your own. All right, so I want you to kind of think along this same lines of reasoning. I want you to kind of ask yourself the same question. So when you're going from line to line, what happened? Why are we allowed to do that? And it should be fairly easy if you use that line of thinking. All right, so here we've got very similar proof, maybe slightly more complicated, maybe slightly more stuff going on the left-hand side. And then again, all of our reasons are blank. So it says fill in the blank with the reason that justifies the statement. All right, so the first line which we're given says 56 plus 7 times 3x plus 2 equals negative 14. All right, so from line 1 to line 2, the right-hand side is staying the same, but some things changed on the left, so it looks like we multiplied through by 7 there. So 7 times 3x is 21x. 7 times 2 is 14. All right, so we've multiplied through by 7 on that left-hand side, which is the distributive property. All right, so from line 2 to line 3, can you tell me what happened? It went from 56 plus 21x plus 14 equals negative 14 to 21x plus 70 equals negative 14. So the right-hand side hasn't changed, but this side got smaller. What did we do there? We added together the 56 and the 14 on the left-hand side, and what is that called? What allows us to do that? That's called combining like terms. Right, so that is called combining like terms. Right now, from line 3 to line 4, right, so it went from 21x plus 70 equals negative 14 to 21x equals negative 84. So what do you think happened there? We subtracted 70 from both sides, and what property allows us to do that? Property that allows us to subtract the same number from both sides is the subtraction property of equality. All right, and then from line 4 to line 5, we've got 21x equals negative 84, and then it went to x equals negative 4. So how did we get x by itself? We must have divided both sides by 21. All right, what property allows us to divide both sides by the same number? The division property of equality. All right, so slightly different problem here. It says the statement, if AB is equal to XY and XY is equal to CD, then AB is equal to CD, is an example of what property? All right, so pause the video, look at that property, look at that statement, look at your properties that you have written down and see which one you think that matches up with. All right, so if AB is equal to XY and XY, so that's just sort of carried over there, repeated, XY is equal to CD, then AB is equal to CD. So look where it kind of just eliminated that middleman, and we have the AB is equal to CD as the result. If you remember, that is the transitive property. So the transitive property allows us to take two separate equalities and sort of just combine them, condense them down into one equality. All right, here's one more. The statement, if A is less than B and B is less than C, then A is less than C, is an example of what property? All right, so let's think about this. We've got A is less than B. All right, so 1 is less than 2. And B is less than C, so maybe 2 is less than 3. So if A is less than B and B is less than C, then we can take those two inequalities, condense them down, and say, well, if A is less than B and B is smaller than C, then A is definitely going to be smaller than C. That's an example of the transitive property again. All right, so transitive property. Sometimes the hardest one to spot whenever you're in the middle of a proof, you kind of forget what that property looks like or what the purpose of that property is, but you want to think of it as like taking two separate statements and condensing them down into one smaller statement. All right, the statement, if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. So we've really just switched the order there. So it went measure of angle A is less than measure of angle A is equal to the measure of angle B. Then it just switched the order. So what property is that called whenever we just switch the order of the equality? That's the symmetric property. All right, so here we've got a little geometry proof. So kind of combining everything that we've learned. A lot of this has to do with algebra. So I've got a diagram here just sort of illustrating what that first line says. It says, fill in the blank with a reason that justifies the statement. Our first statement says the measure of angle CDE plus the measure of angle EDF is equal to 180 degrees. So here's CDE, here's EDF. Those are supplementary. They add to 180 degrees. All right, so that is given to us, or excuse me, that is the definition of supplementary angles. Sorry, that is the definition of supplementary angles. All right, so the next line, we're replacing the measure of angle CDE with x degrees, and then the measure of angle EDF is getting replaced by 4x plus 80 degrees. All right, that's just the substitution property. So we're just taking whatever the value is on the diagram and substituting it in for the measure of those angles. All right, so line 2 to line 3. We have x degrees plus 4x plus 80 degrees equals 180. The right-hand side is staying the same, as you can see, but the left-hand side got a little bit smaller. So we just combined like terms there. Now from line 3 to line 4, 5x degrees plus 80 degrees equals 180 degrees. And then it changes to 5x degrees equals 100 degrees. All right, so what happened there? We subtracted 80 from both sides. So what property is that? The subtraction property of equality. All right, and then from line 4 to line 5, 5x degrees equals 100 degrees, and then we went to the line 5, which says x degrees equals 20 degrees. So what happened from line 4 to line 5? We divided both sides by 5, and what property allows us to divide both sides by the same value? The division property of equality. All right, so our first geometry proof. All right, so here we've got another example, just naming the property. What property justifies the statement? If negative 2 times x minus 9 equals 7, then negative 2 plus 18 equals 7. What do you think happened? What did we do over here to change it to what we see on the right-hand side? We just multiplied through by negative 2, right? So what property is that? That's the distributive property. All right, use the distributive property to complete the statement. Super easy example here. So we have 6 times x plus 4, close parentheses, equals 6x plus 24. All right, a couple of little geometry postulates or theorems that we're going to be utilizing in this section, and then these are really going to carry over to the rest of the semester. The first one is called the angle addition postulate. Angle addition postulate. It just says that if P is a point in the interior of the angle ABC, all right, so then you can take the angle ABC and split it into two little chunks. the measure of angle ABP plus the measure of angle PBC is going to be equal to that big angle. Right, so it just says that if you have a big angle, you can split it up into two or more little chunks, and then those chunks need to add up to that big angle. All right, and then another useful postulate, the segment addition postulate. If B is a point in between 2 points A and C, so think of AC as like a line segment, and B is just some point in between those. It's not necessarily halfway in between or anything. It just says that if you take AB plus BC, that's going to add up to that big chunk. So really the same concept as the angle addition, just with segments. So you can take a big segment, split it up into smaller chunks, and those smaller chunks need to add up to the original segment. All right, so here we have a little, I would say this is kind of halfway in between geometry and algebra. It says write a 2-column proof to prove the following. C is the midpoint of the line segment AD. Right, C is the midpoint of the line segment AD. That's given to us, so you're supposed to assume that that's true. And our goal here, we would like to prove that x is equal to 3. All right, so here's our diagram. We've got the line segment AD. It's been split up into 2 little chunks. I can't tell if they're equal chunks or not. It doesn't specify, or no, it does. It says C is the midpoint. All right, so these are 2 equal chunks. All right, so realistically, we can go in here and add in some little tick marks to show that those little line segments are congruent. Sorry, I'm trying to get to my pen down here. There we go. All right, so this line segment is congruent to that line segment. All right, so let's follow along with the proof. Sometimes I get ahead of myself and I want to just write the proof without looking at the 2-column proof. But let's look at what we're given and what we're supposed to be finding, so where the blanks are. All right, so we've got the proof split up into 2 columns, statements and reasons. The first line says C is the midpoint of the line segment AD. Well, that was given to you. That was what was given. So first line is just given. All right, the next line says the line segment AC is congruent to the line segment CD. All right, we said that that is true because that's the definition of the midpoint. If C is the midpoint, it splits that big segment AD into 2 equal chunks. So that's just the definition of the midpoint. All right, now, second line to third line. You have to be super careful with the notation here. From the second line to the third line, really nothing changed. All that's changing is they're saying, okay, here's line segment AC is congruent to line segment CD. And when you remove that line from the top, that just means the length of the line segment AC. All right, so the second line says the line segment AC is congruent to the line segment CD. The third line says, so if you remove that line from the top and you change the congruent to an equal sign, that means that the length of line segment AC is equal to the length of the line segment CD. And that part's already filled in for you on the right hand side. The reason's already filled in for you. It just says congruent segments have equal length. All right, so that little symbol there means congruent. Congruent segments have equal length. All right, line 4 says 2x equals negative 3x plus 15. So where did they get those values from? That came from the diagram, right? All right, so we were just substituting AC, the length AC, with what they told us that length was. All right, so that's just the substitution property. All right, now you see we have a blank on the left. This is our first blank on the left. So they're wanting you to fill in the blank here. It says 2x equals negative 3x plus 15. And then the next line, it's got 15 by itself. So we need to move that negative 3x over. So we're going to add 3x to both sides. That's going to give us 5x equals 15. And they've already got the reason filled in for you. They said that's the addition property of equality. And then the next line says x equals 3. So what happened from line 5 to line 6? What did we do? We divided both sides by 5, right? And what property allows us to divide both sides by the same value? The division property of equality. All right, a little bit more geometry here. Write a two-column proof to prove the following. So we've got this little diagram, and it says that the ray AC is the angle bisector of angle DAG. All right, so here's DAG, and it says AC is an angle bisector. Do y'all remember angle bisector? What was the definition of an angle bisector? If y'all remember it, it means that that's splitting that angle in half into two equal chunks. All right, and we're supposed to be proving that x is equal to 2. So that's our goal, is we would like to prove that x equals 2. Whatever you're trying to prove, that's always going to be the last line of the proof. All right, so the proof is going to end when we prove what we set out to prove. So that's always going to be the last line of the proof. All right, so let's take a look at our two-column proof here. We've got it split up into statements and reasons. You can see we've got some blanks on the right-hand side. We've got one blank on the left-hand side. All right, so line 1 says the ray AC is the angle bisector of the angle DAG. How did we know that? That was given to us, right? That was the information that was given. All right, so that was given. All right, the next line says angle DAC is congruent to angle CAG. So DAC is congruent to CAG. How do we know that? That was the definition of an angle bisector, right? We said that angle bisectors split up those big angles into two equal chunks. All right, so DAC is equal to CAG because that's the definition of an angle bisector. By definition, an angle bisector splits up that big angle DAG into two equal chunks. Then line 3 is completely filled in for you. It says the measure of angle DAC is equal to the measure of angle CAG. So from line 2 to line 3, they just said, okay, well, if two angles are congruent, then that means their measures are equal. Right, and that's filled in for you. It says congruent angles have equal measure. All right, what about from line 3 to line 4? So measure of angle DAC got replaced by 11x, and then measure of angle CAG got replaced by 9x plus 4. Where do those numbers come from? That's from up here, right? In the diagram. All right, so we just substituted in the values of those angles. All right, so we were just substituting in the values of angle DAC and angle CAG. All right, now the next line, it says we're supposed to be using the subtraction property of equality, and we're supposed to be getting 4 by itself. So what do we need to do to that 9x if we're supposed to be using the subtraction property of equality? We're going to subtract 9x from both sides, right? So subtract 9x from both sides. What are you going to be left with on the left? 2x. Good. All right, now from line 5 to line 6, we go from 2x equals 4 to x equals 2. How are we going to get x by itself? What are we going to have to do? We're going to divide both sides by 2. And what property allows us to do that? The division property of equality. Perfect. Okay. This one's got a lot of blanks on the left. This is the first one we've seen with this many blanks on the left. All right, so we're supposed to write a two-column proof. We're given that the measure of angle GFI is 142. All right, GFI, that's the big angle. All right, so those two angles, GFE and EFI, if you add them together, those are going to add to 142. And we're supposed to be proving that the measure of angle EFI, that's this chunk on the right here, is equal to 44 degrees. All right, so that should be the last line of the proof. What we're trying to prove is always the last line of the proof. And what you're given is typically the first line of the proof. All right, so let's take a look at our two-column proof. This is the biggest proof we've seen so far. Don't let that intimidate you. it's really the same stuff. It's just maybe, you know, done more than once, right? So using some of those properties more than once. All right, so broken up into statements and reasons. First line is completely filled in for you. It says the measure of angle GFI is 142 degrees. That's given to you. Perfect. All right, line 2. The measure of angle GFE plus the measure of angle EFI is equal to the measure of angle GFI. So that's just saying if you take GFI, split it up into those two chunks, GFE and EFI, then that's going to add up to the original angle, GFI. All right, and that is the angle addition postulate. The angle addition postulate that we just looked at a few minutes ago. All right, now, line 2 to line 3. Take a second, maybe pause the video, and see if you can figure out what happened. It says we're supposed to use the substitution property. All right, so it went from the measure of angle GFE plus the measure of angle EFI equals the measure of angle GFI. Left-hand side stayed the same, but the right-hand side became blank, so we're supposed to fill that in with something different. What were you given, what were you told was the measure of angle GFI? Well, in line 1, they told you that that was 142 degrees, so let's just substitute that in on the right-hand side. So measure of angle GFI, we were told in the first line, was 142. All right. Now the next line completely filled in for you. It says the measure of angle GFE is 9x minus 1. That's given to you in the diagram. And then the measure of angle EFI is 4x. That's also given to you in the diagram. All right, so all that information was given. All right, line 4 to line 5. The 142 remains, but GFE gets replaced by 9x minus 1. And the measure of angle EFI gets replaced by 4x. What is that called when we replace the measure, those symbols with their actual value? That's just the substitution property. We're just substituting in what we were told was the value of GFE and EFI. All right, so from line 5 to line 6, we're supposed to combine like terms. All right, so go ahead and combine like terms on the left. 142 is going to remain the same. All right, so if you combine like terms over here, what does that become? 13x minus 1. All right, line 6 to line 7, we're supposed to use the addition property of equality. So let's add 1 to both sides. That's going to give us 13x equals, add 1 to both sides, 143. All right, now we're supposed to use the division property of equality to get x by itself. So we're going to divide both sides by 13. 143 divided by 13 is 11. All right, so now we know that x is 11. Now we're going to use the substitution property to figure out what the measure of angle EFI is. Here's EFI. It's 4x degrees. We know that x is 11. All right, so let's replace x with 11. 4 times 11 is 44. And that's what we're trying to set out to prove, so we're all done. Last one, this one's a segment problem, so you're probably going to be using that segment addition postulate that we saw earlier. All right, we're supposed to be writing a 2-column proof. We're given that the length of the line segment KM is 41, so KM is 41. And we would like to prove that KL, that's that chunk on the left, that the length of the line segment KL is 19. All right, so let's follow along here and fill in our 2-column proof. KM is equal to 41. That was given to you. All right, so line 2, KL plus LM, KL plus LM is KM. Well, that was the segment addition postulate. It said that if you break up a line segment into 2 chunks, then those 2 chunks need to add up to that big line segment. All right, and what were you told was the value of Km? So we're going to substitute in what we were told was the value of Km. Well, Well, they said that was 41, right? That was line 1 of the proof. All right, so that's line 1 of the proof, says Km is 41. All right, the next line is totally filled in for you. It says KL is equal to 2x minus 3. LM is equal to 2x. That was given to you in the diagram. All right, line 4 to line 5. Let's see. We've got 2x minus 3 plus 2x equals 41. All right, so we're really kind of working off of line 3 here, kind of combining line 3 and line 4. All right, so if KL plus LM is 41, and KL is 2x minus 3, and LM is 2x, well, let's substitute that in. All right, so that's the substitution property. That's supposed to add up to 41. All right, so here we're supposed to combine like terms. You can see that the 41 stays the same, but we're supposed to combine like terms on the left-hand side. All right, so if you combine like terms, what do you have on the left? That would be 4x minus 3. All right, now, line 6 to line 7, we're supposed to use the addition property of equality. So let's move this 3 over. So we're going to add 3 to both sides. That leaves us with 4x on the left. Adding 3 to both sides, that's going to give us 44 on the right. All right, line 7 to line 8, we're supposed to use the division property of equality. So let's get x by itself by dividing by 4. So if you divide both sides by 4, x is 11. Just so happened that x was 11 in both of those. It's kind of weird. And now we're supposed to find the value of KL by substituting in. So let's go up to KL. Let's replace x with 11. Right, so that's 2 times 11 minus 3. And what does that simplify to? 2 times 11 is 22. 22 minus 3 is 19. That's it. All right, so you're going to see some lots of examples of these proofs. I know that this is something that you may not be familiar with, something you maybe haven't done in a while or maybe haven't done ever. So give yourself some grace. I'm not asking you to be perfect at this. I just want you to try, and I want you to give it your best effort. And I'm going to give you lots of examples so you have lots of stuff to practice with. And please let me know if you have any questions. I can't help you if I don't know what you're struggling with. So if you let me know what you need help with, I'm happy to do whatever I can to help you get better at these 2-column proofs, because we're going to be seeing them for the rest of the semester. All right, you guys, I'll see you in the next video. Have a good day.